Hi everybody, welcome to the first video on vehicle systems. A bit about me. I am Gurfateh Singh. I'm studying Bachelor of Technology in Curtin University. This is the video 1 of Computer Technology Project 1. This project is on developing a vehicle speed monitoring system that will control your speed and not let you overspeed. In Australia, there are very strict and defined rules for every driver to follow on road. Most of the drivers follow these roads and drive very safely, but occasionally a person gets preoccupied while thinking something else, being in a stress or not paying attention, which can lead him into an accident or a hefty fine. While fines are good for the government as they increase the revenue, but it's not so pleasant for the payee. There is also an increase in number of rear-end collisions in Australia, which are not fatal, but it certainly hurts the pocket and is a general annoyance and unwanted stress. The goal of this system is to reduce the risk of speeding fines and warn the driver about the possible rear-end crash. And also, additionally, we will be adding a fatigue check camera that will warn the driver to stop driving and take some rest. So why do we need such a system? Increase in speeding fines, reducing the risk of crashes, and controlling driver fatigue. This design will contain two servo motors. This is a general product feature of the design. This is a 3D model that we created in Google SketchUp. So this will have Arduino with a GPS and two servos. This will help us always remain under the speed limit. The design will have heat-proof padding because of the engine heat, and it will also have wireless functionality to get the data from Google Maps API and the weather data. So this is how a traditional throttle body works. Traditional throttle body has this cable that comes from the car and into this spring-loaded mechanism, which is detailed here. Our system will be placed between the throttle cable and between the throttle pedal, so we will have to cut the cable in two to make it work. I will explain in detail in the next slide. This is a video description and the 3D model of the vehicle systems. This is 3D SketchUp made in a Google SketchUp. Let me erase this. And the top view. This is the Arduino. And this is the little GPS sensor that we have. A tube is emptied so the cable comes in and connects to the servos. These are the two servos. That is the input and the bottom one output. This will have a heat padding from the engine, and this is the rough sketch of a 3D model. There will be only 3 components in this system, as the Raspberry Pi and the displays and the camera are gonna be a separate unit. These are the design components that are required to make this system. There will be one Raspberry Pi that will be located in the car. There will be 2 Arduinos that will control the servo and the Wi-Fi connectivity to get the best of the data from Google Maps API about speed limits and the weather data. There will be 2 servo motors as described. There will be 1 camera used that will be used to detect the fatigueness of the driver. There will be 1 ultrasonic sensor that can detect a sudden stop in traffic to avoid rear-end collisions. There will be 1 GPS and a Wi-Fi sensor, Wi-Fi just to get the data and GPS to actually know where the vehicle is located. There will also be 1 heads-up display that will contain the information about current speed and the speed limit. There will also be a warning speaker that will alert the driver about basically any warning. And there will also be an override button on the steering wheel. That will be the kill switch of this system. There are a few problems with this system that needs to be fixed, which will be fixed as we further into this program. So the throttle cable that goes from the pedal to the machine actually needs an override physical kill switch to disconnect from the system completely, as in an event of the whole system failing, we will not have a breakdown situation with the car. The system also needed data storage to actually store the speed data so that it does not need to connect to the Wi-Fi and get the speed limits every time the driver has to drive over the specific road. The system needs a software kill switch instead of emergency or loss of signal. For example, in some cases you have to accelerate to get out of the situation, there will be an instant override button that will let you do so, and that will let you overspeed. Another problem is the encasing that has to be on the system near the engine has to be heat proof, prevent from melting from the engine's heat. There also needs to be a spring-loaded mechanism that mimics the mechanism of the throttle body to gives sufficient travel back of the pedal, otherwise the pedal will just be stuck on full speed, which will not be very good. These are the problems that we are facing, but I'm very sure that we will get rid of all of these. And now we come to the timeline. So for the first week, we basically created a 3D model. By the third week, all the mechanical limitations and problems were identified. As we go around to the 7th week, there will be ordering of Arduinos, Raspberry Pis, finding proper deals, even sensors, ultrasonic sensors, and the servos will be ordered, and we expect those to arrive by week 10. A prototype would be created by week 11 that can be just tested in a model environment by putting it on a remote controlled car. By the week 11th, we'll be testing all the bugs in the program itself and any problems in the code that causes errors. Then we will be adding a sonar, that is the ultrasonic sensor, and setting up the camera that has the facial detection in Raspberry Pi. By week 25, we will be fixing all the physical limitations about the override switch and the kill switch. By week 28, we will be testing the overall code for the face detection and the ultrasonic sensor, and all the final touches and bug fixes should be done by week 40. Thank you.